right, you tell me if you have any questions. This guy, when you can put all your pieces in and you can just work them out, do them in your calculator, not your y equals part. You have all the things on the right-hand side. Whoops, they're all there. So just do them in your calculator. Rule of thumb, dollars round to 2 decimal points. Make sure you keep me the dollar sign. You do have to know Kurt, and you do have to know the other formula, the accrued interest formula here, the compounded interest formula. Make sure you know both of those. All right, stop me if you have any questions. I think we did 1 and 4, didn't we? We did a couple of these in class, right? Did we do 2?
We did 1, 2, and 4.
1, 2, and 4. So we did this one. Now again, just show me a sketch of a graph. You graphed this, and you wanted to see where it intersected. Just kind of show me some sketch of a graph that would show me your work. Because algebraically, we need logs to pull down that exponent. So right now we're doing all these graphically. Then, believe it or not, when we do the logs, we come back and we visit these sheets again, which makes life easy. You already have your equations, then we solve them algebraically. So this is the same, pretty much the same as that one. Determine when is time. You have your principal, you want it to accumulate. You have your rate, it's compounded monthly, and it's 12. So again, just kind of give me some kind of a sketch. It's growing, and where are they intersecting? And make sure you label your answers with your applications. Good? You're still good? Okay. We did this one, right? Determine when it doubles. We said, don't forget, with the doubles, you could set any amount you want for P when you double it. So if I start like this, I set 100, and I'm going to double to 200. As soon as I divide it, there's my 2 to 1. So whatever you set, it's easier probably just to do 2 to 1. It makes your windows a little bit nicer. You can go back to a regular window, but you can leave your 100, your 200 if you want to, and intersect your 100 and your 200. That's fine with me too. Okay. This one, did I do this one with you? The rate? We did part, right? We discussed that with this one, your rate's going to be very, very close to your x-axis. So let's just put this one in your calculator for those of you that had a little trouble in the calc. Okay, so we know what our first one's going to be. Our first one's going to say 1580. We're looking for a rate this time. Your rate is usually a percent. When we put it in your formula, it's a small decimal. It's less than 1. So your answer is going to be less than 1. Your answer is going to be really small. So I put plus. And you could put x over 1, or you can just put the x since we're doing this annually. And we're raising this. This always worked before, and now it's not working. And we're raising this 8 years. We're doing this after 8 years. We want to see when does this happen for $3,000. So when I set my window, I know my mins are zeros. I don't want to know what my max is yet. So I'm just going to say 10 for now. Just to show you what happens here. My Y max, I want $3,000, so maybe I'll make this $3,500. Okay, if I graph this, it's graphing. I just can't see it graph because my R, my rate is really, really small. It's like 0.08, 0.10. It's far, far less than 1. It's actually sitting along this axis. If you do an intersect at this point, it's going to find it. It'll find it. Look how small that rate is. if you can catch that part that your rate is so small, set your y, your x max, from 0. It's never going to go greater than 1. Set it to 1. Maybe increment by 0.1s. And you're still going to see. You can barely see it because it's 0.08. It's less than 10%. Maybe that and it makes it easier for you to spot it. It's there if you didn't set your window to that. It's just that your rate gives you a really small value. Your time, you can kind of figure these out. Your time, I would estimate from usually 0 to 25 years. No, not 0, like 1 to 25 years, somewhere. That's what we normally say. Could be a little higher depending on what they're asking for. Your rates are small, 8%, 6%, 10%. I doubt you see a 50% rate or a 100% rate. And your time is usually, and your amounts are the ones, your investments are the ones that's going to change. But it's kind of nice when they do this investment because you can figure out your Y max based on that. And if you need to find your Y max, you don't even need your Y equals. Okay, and I gave you another one just like this as well. Again, your rate is small. This was a nice rate, 10%, a little bit more than 10%. So again, you can keep your X value between 0 and 1. It's not going to be greater than 1. 1 is 100%. It won't be greater than 1. So put your X value from 0 to 1, even 0.5 if you want to. It'll spread that out a little bit more. And do your intersect. So all your graphs are pretty much looking the same. You're in quadrant 1, you're growing, you're intersecting. Pretty much they're doing about the same thing. Are we good? Okay. Determine how much time. I'm looking for my time this time. And my time usually is between, I would say less than 50 years. The higher you make your x-axis, the more sharp you'll see your curve go up. Be careful of your compounds. Make sure you change your compounding. And for something to double again, I use 2 to 1. You want to use 100, 200, 1,000, 2,000. All that means is you're going to have to change your y max. That's all that means. Is everybody comfortable with the calculator? I think you guys are you getting more at ease with the calculator? Changing your windows? Yeah? Okay. And again, do your intersect. Don't do traces. Don't do a trace. Do an intersect. And then these guys, you're just putting your money in and watching it compound again. We kept it steady at 5 years. We did annually, N is 1, quarterly, N is 4, monthly, N is 12, daily, N is 365. The daily should yield you the highest return because we didn't do PERT in here. PERT will give you the best. It is not a lot more than a daily. But you can kind of see where the growth is. I'm sorry? I did give you PERT? Oh, is it underneath this? Oh, okay. Sorry about that. It does not let me move this thing down. Someone must have moved this. And I can't move this down. Everybody okay with these? Oh, I think it's here. So today, Today we're going to do another set of applications today. These were the easier ones, the money, since we had just started doing those. So let's go over a couple of examples. I don't have this example sheet for you. I don't know why. I left it out and must have thrown it out. And that I didn't get it back from when they copied it.
had to go to Woody because you're supposed to be in the office.
Alright, so now we're going to take a look at a different set of applications. Now, these applications, and I don't have this sheet for you, but we'll do some of these and then I'll do some on the homework with you as well. Write this down. They all work off of this. So did your interest. Your interest was this. Same thing. There's that. There's a rate. There's a time. They all work off of this. The one thing it does not do is compound in these. The only time you use the compounding part, the annual, the daily, whatever, is when you calculate money. But we may have cycles in this. We actually do half-lives, which you probably do in chemistry. Dr. I explained the same half-life as we do. Your formula looks a little bit different. You use different letters to represent it, but basically, they all work off of this. A, and write this down, is your initial value. Whatever you start with initially. 300 units of bacteria, 100 units of bacteria. B is your rate. If something doubles, this is for your rate. We're going to make B equal 2. If something triples, B is equal to 3. If something takes a half-life, what do you think B is? 1/2. Okay? If something like a population increases, if they give us an increase, then B is going to say 1 plus something. Write these down because these are all the cases you're going to see. I didn't have this sheet, so we're just kind of writing notes right now. If it's decreases, it's going to say 1 minus something. These are the way your rates are going to go. Now your time is usually in days, in seconds, in minutes, in hours, in years. Sometimes your time has a cycle. And a cycle would mean every 4 days, every 5 years, like your half-life. Every 20 years, that's a half-life type thing. So when we do your time, if you have a cycle, we divide it by whatever it says, like days every 4 days, x over 4. And we'll do some of these together, so you'll see them. So we work off of this basic formula. All of your exponential ones should work off of this, even your interest problems. And the one thing I don't want you to confuse is the compounding. This that we're doing today has no compounding. That's only with your money. All right, so let's try one. The number of bacteria triples every 4 days. This is my rate. This is my cycle. Okay. Initially, 1,000 units are present. How many are present after 4 days, after 8 days, after 12 days, after 1 day? Let's just start like this first. We start at day 0 with 1,000 units. When is this going to triple on what day? Day 4. Day 4, this should say what? 3,000. Then another 4 days. What should it say? It's going to triple. 9,000. Right? It's going to keep tripling. So we see a pattern. Right? So when you put this in your calculator, if you don't see that in your table, then something went wrong. So we're going to start like this. What's A? What's your initial units? 1,000. What's your rate? 3. I'm tripling. I'm going in days. X represent days, but how many days to complete a cycle? 4. So divide by 4. Okay? This is going to tell me how many I'm going to have. Okay? So they want to know in 12 days. Where do I put the 12? In the X. Good. Over the 4. The 9. over the 4, the 4 over the 4, the 8 over the 4. Now, an easy way to do this is put this in your y equals. You can put each one in your calculator, and you can do it that way, or you can go to your y equals. And you can put it in here and look in your graph. Okay, so let's put this in your y equals. We have 1,000 units. We're tripling. And we, oops, doesn't like my parentheses today. Doesn't like any of my numbers today. We're tripling, and we're doing this x divided by 4. Every 4 days. Okay, let's look at your window. What quadrant should this be in? Quadrant 1. We don't have negative time. We don't have negative bacteria. So the 0, the 0. The x max, I'm really not sure what days I am, but I do know I'm just calculating up to what day. 12. So let's just go 20. I just want to see it over 20 days. My y max is tricky. I can see I'm going pretty fast. So maybe make it pretty high. But for some odd reason, this is just not going. I'll make it 100,000. I don't really care what my graph looks like as much, because I can go to my table and find this. So I can see my bacteria increasing, increasing, increasing. Okay. And my bacteria increases exponentially. Here's my table. At the 0, did we expect 1,000? At the 4, did we expect 3,000? Yeah, we knew this would happen. And at the 9, we expected, at the 8, we expected 9,000. So that's a good indicator that you did the right thing. The reason I say that too is because sometimes we forget the x divided by 4. We know it when we do the table. We say 4 days at 0, at the 4, at the 8. But we sometimes forget to put it in. So you can calculate these without using your graph, these particular ones, or with your graph. Okay? And when things grow exponentially, they grow. They grow fast, especially bacteria. Yes?
When you're looking them on the graph, do you have to round them to the 3 decimals?
3 decimals. You might have to just scroll over the number because they're so high. What happens in your graph is, and that's a good point, what happens in your table, my board, I'm clicking on the wrong thing. This is probably my whole day. When you're up here, just go over here and round, like this. They'll show you the whole thing. Sometimes when you get pretty far down, they write these in exponential numbers. When they get too high, see the exponential numbers, e? That means 2.19 e to the 6th, that's 10 to the 6th power. Move your decimal 6 places over. Because the numbers are so high with these. Exponential growth and decay are pretty high in your growth. Okay, let's try another one. Population increase and decrease. So your population decreases 2.5% each year. Your initial population is 100,000 in your little town. You want to know when will it be 95,000. So you start like this. What's your initial?
100,000.
100,000. And it's decreasing. This is where I'm going to decrease. Decrease is 1 minus the rate. And again, to my time. So what is my rate in decimals?
0.025.
Good. 1 minus 0.025. And you can leave it like that. So you're either going to say 100,000 times 1 minus 0.025 to the x, or if you calculated this, this is 0.975. When you do a decrease, it means this is how much remains or is retained every year. I don't want 100% of my population. I want 97.5% of my population to be retained. It's 100 minus 2.5. I want to lose 2.5 of it, and I would want to retain 97.5%. So when you put this in your calculator, it's kind of a nice way to start this. Here's your 100,000. And that'll help you figure out your Y max right there. You're doing 100,000 and you're decreasing this. So 1 minus 0.025. Be careful of your decimal. I didn't get the 1 minus in here. I think it's this side of the board for some reason. Let me move it over here. And you want to raise this to the x. This is the guy you need to figure out when. So now, this is just your basic graph. What do you do with the 95,000? The y2. Good, we want to see where they're going to intersect. No different than we did before. Okay, set your window up. Again, you're not really sure what your x max is. It's not a tremendous amount of years. Because you're not decreasing this one that far, right? So maybe 10 years. I would go maximum 10 years. And see what happens to me.
You get 10 years.
Okay, hang on. And this guy, set it 100,000. You want to see the decrease. We're decreasing. And did we fit it in our screen to do an intersect? Mm-hmm. Can we do an intersect on this? To see when this will happen? Again, on an increase and a decrease, when you do an intersect, just hit it 3 times. So it's not going to take too long. 2.026 years to reach 95,000. And that makes total sense, doesn't it? We only went from 100,000, we only lost 5,000 people. So, not going to take that long. If you find that you can't intersect, change your x max. Usually your y max is pretty easy to tell when you do a decrease, because that's the decrease right there. This is important though, this part right here. Decrease, and this guy is an increase. This kind of works like your money does. When you increase your money, the 1 plus rolls it in to carry on for next year. But there's no compounding in this.
I didn't get that.
You didn't get what?
Years, the 2 years.
The 2 years? Did you put this in? Let's see.
I see a window, I think we
I did
were
100,000. 1 minus my 0.025.
Oh, never mind. I put 0.25.
Yeah. Then you're decreasing very fast. Be careful of your decimals. Those people will be moving away like crazy. Okay, and here's your favorite half-life. A half-life means it decreases by half that amount every certain cycle. So again, you're going to start like this. And your half-life is 12 days. This is your cycle. There are 4 grams after 10 days. What was my initial amount? What did I start with? So where does the 4 belong?
X.
In the Y, the A, the B, or the X? The Y. This is what I was ending up with. I don't know what we started with, but I know my half-life, there's my rate, and I'm going days. X will represent my days, but am I half-lifing every day?
No.
Every how many? Every 12 days. Do I expect A to be larger or smaller than 4? I'm half-lifing.
More.
More, right? Because I keep half-lifing. Now, be careful of this. This exponent only belongs to the 1/4. It doesn't belong to a. So I can put this in my calculator, but I can technically divide this out. And I'm going to put my x of 10 in here after 10 days. So think this out. 10 days, did you actually hit a cycle? No. So estimate a. So what's it? 6? Can't be 8, right? It can't be 8 because I haven't hit my 12 days. So somewhere between 6 and 8 should be your answer. Now, you have a choice. You can put this in your y1 and your y2 because you only have one x value and you can see where they intersect. Or because this is here, you can divide both sides by this. 1/2 of this. You can do 1/2 raised to the 10 over 12. You can do it either way. You can put it in your calculator and see where they intersect, or you can do this one algebraically and get this one. And let's put this in your calculator as well. Back to a very small screen. Okay. You want to probably change your y's. Your x, I'd leave at 10. Your x is probably a value. Your x is good. We know it's not going to be bigger than 8. And you want to change your y max here. Oh, maybe 10 also. Let's try. And there it goes. It looks like a straight line. But if you change your x max to be a little bit more, you'll actually see more of a curve. Oh, maybe not. And then do an intercept. Okay, does it make sense? And what did you come up with?
7.127.
And didn't we say this would be less than 8? We said it would be less than 8. We had 10 out of the 12 days. We didn't hit 12 days yet. So we can't possibly be half of it yet. Okay, assume the number of bacteria in a certain bacterial culture doubles every 3 hours. Underline the things that are important. They double every 3 hours, and initially there are 2,500 units of bacteria present. How many bacteria are present after 6 hours? And then we're going to graph this, and we're going to see when your bacteria hits 10,000. Now, start with your basic equation. What's A? 2,500. This is our initial. What's my rate? 2. I'm doubling. Okay. Here is my x. If I put x, this would mean every hour. Am I doubling every hour? What's my cycle? Every 3 hours. So if I made my own chart, I would say at the 0, I started out at 2,500. Every 3, at the 3, I'm doubling. 5,000. When do I double again? 6, and I would double this. This is a good indicator to do, because you can think that through. And then when you graph it, you can actually see it in your table. So now I want to know how many will be present after 6 hours. Well, hours is here. Hours is my time. All I have to do is substitute in 6. Now remember, the 2 gets the exponent. You don't multiply 2,500 times 2 and then raise it. The exponent only belongs to the 2, so it's like 2 squared. 2 squared is 4. times 2,500 is what? 10,000. Didn't I expect that after 6 hours? Right? If I forgot to do my cycle, I would definitely not see that match. Okay, I don't want to be doubling this every hour. I want to be doubling this every 3 hours. Okay, we're going to draw a graph of your bacteria during the first 24 hours. So let's draw a graph. All right, so my graph says I started with 2,500. I'm going to double. I'm going to double. It just does not like my parentheses today. I'm going to double x divided by 3 every 3 hours. Oh, why the divides? You know why? Because in the first period I said this one's so much smoother than my other one. Okay, so we should see this increase. What quadrant should this come from? 1. Okay, now I want to show you something. We're going to maybe go to 6 hours, maybe go to 10. Well, maybe go to we'll just do 10 right now. Our Y max, what should our Y max be? 100,000. Eventually, we're going to look for 100,000. So just make it 120,000. Right? Sometimes if you just change the scale, you don't get such a dark line. Okay. All right, so we can see my bacteria growing for 10 days. Where did that graph come from? Did it start in quadrant 1? If I change this window and I just go from -10, don't all my graphs come from quadrant 2, my exponential curves? Don't they come from quadrant 2? Either I'm getting this, there's my exponential increase. Where does my decrease come from? There's my exponential decrease. So technically, it comes from quadrant 2. If you're looking for a complete graph, it came from quadrant 2. If you're looking for a situational graph, it only exists in quadrant 1 because we made it that way. We can't have negative hours. That's what your applications do. It limits it to quadrant 1. But they technically came from quadrant 2. So now when we look at this, we can kind of see your graph a little bit better. We can see limit this, go into quadrant 1 only, and that's where your application exists. Now when we want to find the bacteria to 100,000, you do it the same exact way. You come down here and you go 100,000. And you intersect. If you have to change your window, right? So we're going to have to change our window. What are we going to have to change? X max. What should we make our X max? 2 ways. We can just guesstimate, or we can go to your table, and we can see, let's start at the 0, increment by 1. We can look at your table and see, when did we get close to 100,000? When do these guys equal each other? We can do this. Well, we're getting close. Or we can just guesstimate this. Maybe 20. And see what it looks like. I want to see if I intersect by 20. If not, I'll change it again. Can I do an intersect on this now? Okay? You can't ruin this. You can't do anything wrong to it. If you do anything wrong, go back and start, do a Zoom 6, and start over. Some kids change their graphs, and they get all confused, and I don't know how to get back to where I was. Just do a Zoom 6, and change your mins back to 0, and start again. Go to your table that time, and look to see what it is. Okay, so when we reach the 100,000, it will be 15 15.966 hours, right? Because our denomination here for time is hours. And we set y2 equal to 100,000. I forgot what it was, whatever the answer was, hours. Guys okay with this? Let's set up one more. Let's set up your population one.
Wait, what was
I forgot on my calculator what it was exactly. Oops, I keep pulling up the wrong thing. 15.966, it was that. Hours. All right. The population of the town is currently at 123,000, and they are decreasing at a rate of 2.375% each year. Write your population as a function of time. So again, start like this. What's your initial population?
123,000.
Okay. What's my rate? I'm doing what?
02375.
But I'm decreasing by this, right? This guy you have to say 1 minus, because I'm decreasing by this. Okay? This is my population. Now, what will it be over time? Time is in what? Each year. X is my time in years. Okay. Now, I'm decreasing. So, if I'm making a complete graph of this, what quadrant does this exactly come from? 2. So 2, it starts coming from 2 and it starts decreasing. This is my complete graph.
That's all you have to do.
This is my complete graph. What's the situational problem? The problem situation. Quadrant 1 is where I'm decreasing. Quadrant 1 is where I'm decreasing. I should have made it a little bit sharper than that, but quadrant 1 is where I'm decreasing. So what we look like is this. We started out at a max, and we decreased. We want to know when. When means we need to find what? Time. So that this is my time. When I reach 50,000.
So then you put what?
And you put that in your y2. You can leave this rather than subtract it. Just leave it like that. So this goes in your y2, and this guy in your y1. Now, in terms of your x, you're going to see a decrease. What do you think is a good x value for this? An x max? Let's just think about it for a second.
Well, it's going to decrease it.
It's decreasing, and I have to go more than half, right? I have to go more than halfway down. So if you're going to graph this, what should you put as your x max?
140,000.
No, that would be in your, y's, right? Your time, maybe 30 years? 30 years, would you think?
No. 40.
40? So if I can't cross after 30 years, do I change it and make it higher? Yeah. Go to your table if you want to see exactly where that was. So everybody can do this part? Okay, so you can finish up that one. And you can